One machine appears to be changing the way cars are made in the future, and it's a very big thing. It requires 24 flatbed trucks to get it from the manufacturer and doesn't even fit inside the original Tesla factory. It weighs roughly the same as 5 space shuttles. Why is it needed? How does it facilitate the quick production of Tesla Cybertrucks? Make sure to stay tuned until the end to find out. Hey guys, welcome back to another exciting video. Today in this video, we'll be discussing how Tesla's GigaPress assists in the rapid production of the Cybertruck. But before we begin, make sure to hit that subscribe button to make sure you never miss any updates or videos from us. That said, let's get started. Elon Musk, as we all know, is a man on a mission. In addition to launching civilization to Mars and playing Pong with his lovely monkey partner, he's constantly thinking of genius ways to advance his day job at Tesla, which involves ushering in the era of electric vehicles. A tiny die-cast, the Hot Wheels toy car on his desk, is said to have served as the inspiration for his most recent major idea. Musk wondered what the realistic size limit for a die-cast vehicle was, and then discovered there was no real reason why full-size cars couldn't be produced using the same design principles. This is Mr. Build the machine that makes the machine after all. His entire job is to find these kinds of efficiencies. Therefore, Musk decided he was no longer pleased that the rear underbody is made up of a whopping 70 different elements when designing the radical Model Y redesign, which would integrate Tesla's next-generation batteries into the chassis of the current iteration of automobiles to roll off the manufacturing lines. Of course, each of these 70 pieces needs to be screwed, welded, or otherwise adhered to its neighbors. That's a difficult and risky procedure that takes up a lot of room on the production floor, a lot of effort, and a lot of time, and it invites dumb mistakes. Sandy Munro, a well-known engineer and consultant in the car business, made the point crystal clear when he told Musk that the back of his Model 3 looked like a patchwork quilt. In order to produce enormous self-contained sections, initially the rear underbody of the Model Y, Elon Musk stated in April 2020 that he had acquired the 2 largest casting machines in the world from Italian engineering company Hydra. Later that summer, the massive machines, each 20 meters long and 6 meters high, were placed at the company's factory in Fremont, California. These enormous gigapresses, which are so large they couldn't be installed in the plant and had to be hastily covered over with a crude shelter in the parking lot, will, in Musk's estimation, eliminate 300 of the firm's robots. For Tesla, this decrease means a clear simplification of quality control procedures and the production challenges of manufacturing and pipelining 70 distinct pieces. Naturally, this lowers the price of the cars, making them more affordable for customers. Previously, assembling those 70 pieces like a jigsaw required a complex and pricey CNC computer numerical control procedure. Now that the entire rear underbody is cast by the GigaPress in one piece, the entire CNC face may be completely avoided. Experts predict that gigacasting will reduce the cost of manufacturing the rear underbody by 40%. Additionally, the manufacturing body shop will shrink by 30% thanks to the new single-piece casting design. So how does it function in procedure? All die casting, whether it be for toys, golf clubs, or Tesla chassis, essentially operates on the premise of pressing molten metal into a reusable mold. The mold is opened and the freshly shaped metal is removed when the metal has set into the shape of the mold. In Tesla's case, the metal in question is a sophisticated and distinctive proprietary alloy made up of traces of lead, copper, magnesium, iron, zinc, titanium, and about 85% silicon, together with about 90% aluminum. The alloy is heated to 850 degrees Celsius in an oven powered by natural gas, at which point the ingots become liquid. Aluminum oxide-based waste slag is removed before the alloy is pushed through heated pipes and cycled to prevent setting. To keep undesirable contaminants at bay, argon gas and a rotary degasser are used. The entire mixture is then run through a silicon carbide filter to get rid of tenacious lumps larger than 25 micrometers. Robots spray 35 milliliters of soybean oil within the mold to lube up the procedure before insertion. After that, the mold is sealed, and a vacuum is then created inside. The hot metal is then quickly pressed into the mold to prevent it from solidifying, allowing with a little extra lubrication to keep it from clinging to the sides. The mold is then opened once it's full and chilled to 400 degrees Celsius. The newly formed metal item is then robotically transported to a tank that helps it set by maintaining a temperature of only 50 degrees Celsius. The entire team is then x-rayed to make sure it's roadworthy, and any unhelpful surplus is removed using a mechanical trim press, all while adhering to painstakingly specified tolerances. Lasers are used for the last-minute trimming, after which conventional drills are used to prepare the component for assembly into the vehicle. Does it seem too good to be true? Critics have noted that replacing 70 pieces with one part has a significant drawback in that, should the one part become damaged, as may occur in a reckless accident, replacing the entire rear underbody would be cumbersome and prohibitively expensive. The car's crash absorption rails can be taken off and replaced with a fastened portion from collision repair, Elon Musk wrote on Twitter. The car is obviously a total loss if the crash is serious enough, but the majority of other modern vehicle designs also fall into that category. Another issue from the standpoint of manufacturing is that during each casting, minute particles of the mold may inadvertently transfer to the part itself. The mold itself eventually grows too large, although these are obviously replaceable GigaPress components. Additionally, the lubrication stage significantly reduces this problem. GigaPresses with a clamping force of 6,000 tons are now in use or being installed in Fremont, Berlin, Austin, and equivalent machines in Shanghai, according to Tesla, aren't strong enough. Musk is reportedly looking for even bigger equipment with a clamping power of 8,000 tons to produce the long-awaited Cybertruck. Will this mean that the other manufacturers will have to do the same? According to JP Morgan's industry study, large corporations will find it difficult to fundamentally reimagine their own production processes as Tesla can. However, JP Morgan believes that smaller EV startups and cash-rich, agile Chinese companies will be keenly watching it soon should be investing in their own gigapresses. Any 21st century corporation worth its salt will seize the potential to minimize the space taken up by its factory floor, the number of robots it employs, and the amount of time wasted jigsaw assembling automobiles. Additionally, if everything goes according to plan, Tesla will start full-scale production of the Cybertruck in less than exactly 1 year, though production preparation will start much earlier. According to a recent report from Germany, Tesla has ordered production equipment from numerous German businesses that would reportedly be used to make Cybertrucks. Unnamed sources told TeslaMag.de that the recently ordered systems were going to the Texas Gigafactory. This is where the Cybertruck will be constructed if everything goes according to schedule, starting in July 2023. According to the original story, these businesses have already provided equipment for Giga Berlin and Giga Shanghai. Despite Cybertruck's stated yearly manufacturing target of 250,000 units, the source adds that the current purchase will be sufficient for a production pace of up to 75,000 motors annually. This looks to be the perfect amount to give the top-of-the-line tri-motor Cybertruck complete powertrains for a full 12-month run. Late in May, the Italian metal casting expert Eager Group reported that it had started construction on a 9,000-ton gigapress for Tesla, which was specifically required to produce the vehicle's single-piece back part. The smaller 6,000-ton units Tesla previously purchased from the business and is currently using would not have been adequate for the Cybertruck or other larger casting works. Whether Tesla will actually meet the timetable to begin Cybertruck production next summer is the crucial question, though. Even though Tesla stopped taking Cybertruck orders from customers outside the US, it excluded the pricing and version results from the official websites a few months ago. Interest in the divisive truck is undoubtedly still high. Order holders continue to believe that they will eventually receive their vehicles. In any case, these large machines that resemble house-sized seem destined to have a lasting impact. How do they feel? Will the advancement of the casting system result in autos having progressively fewer parts? Let's know your thoughts in the comment section. And that's all for today. Thanks for watching. If you enjoyed it, please like, share, and subscribe to our channel for more such amazing content. See you in the next video.